Okay, today we're doing graphs of factorized cubic functions. So when we're, this is when it's in the format like up here, the y equals ax to the cubed plus bx squared plus cx plus d. So the way we're going to do it is we're going to do our factor theorem to get the first factor, then we'll use division. If that didn't work, we can use, we can check it, maybe use quadratic formula, or you could use the patterns, if it's a pattern, one of them, and then, oh sorry, there it is. So patterns. Remember that the d value is actually the y-intercept. Now, when we're drawing our cubics, if we have a positive cubic, so what I mean by that is the cubed unit is positive. So the leading term is positive. So when you have that, it starts down in this bottom corner and you go up, down, and that. So here would be your, say, your 3 x-intercepts. So a positive cubic, so if the number in front is positive, starts here. So we would say starts down here. If it's negative, it starts up in this quadrant and you go 1, 2, 3. So there would be, say, your 3 x-intercepts. So this is if x is a negative. So if you have a minus cubic number, okay? So it's going to start up here. Okay, so let's do an example. So we've got sketch this graph, this cubic. So we're going to use the factor theorem and find a factor. So I'm going to try p of -1. So if I put -1 in, I've got -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. So I get -1 plus 2 plus 5 minus 6, and that equals 0. So therefore, we know that x plus 1 is a factor. And then we can go about doing our division. So we'll do our division next. So x plus 1 into the original polynomial cubic. And so off we go. So x squared, x cubed, x squared times 1 is x squared. Then we minus. So that becomes x squared. So x into x squared goes x times. Bring the 5x down. So x times x is x squared, and x times 1 is x. We're going to subtract that. That gives us -6x. Bring this guy down, minus 6. So x into -6x is -6. So we get -6x minus 6. That subtracts, and we get 0. So now we know that our factors, if we've factorized, that y actually equals x plus 1 and x squared plus x minus 6. Okay, so then we can factorize this quadratic, and I might use plus 3 and minus 2, because that would give me minus 2x and 3x, and that adds to give that middle number. So now I've got y equals x plus 1, and then I've got x plus 3 and x minus 2. Okay, so essentially you now know that the x-intercepts are -1, -3, and 2. So we can go about and let's draw it. Okay, so we'll pop in our x-intercept. So we've got one at -1 and one at -3 and one at 2. So here are our 3 x-intercepts. Now, because this quadratic is a positive, we're going to start down in this quadrant and we go up, down, and around. So if I was writing my coordinates, I should put that would be 2, 0, -1, 0, and -3, 0. Now we can't forget about the y-intercept, but we can see up here that it's -6. So we can put 0, -6 in, and there we've done we've sketched this cubic, sorry. Okay, when we sketch the graph of this one, y equals negative x minus 1 bracket x squared plus 4x plus 5. So note this is a negative, so it will start in the top, at the top. Now, if we have a look at also this, factors of 5 are not going to add to 4x, so we can't, the cross method's not going to work. So when the cross method may not work, we would maybe check the discriminant to see if we are going to get an answer. So discriminant is b squared minus 4ac, so this would be 4 squared minus 4 times 1 times 5. So 4 squared is 16, and then we've got minus 20. So we have negative. So the negative discriminant means no solutions for that part. So this graph actually only has one intercept. So let's find that one. Okay, so that one intercept is x equals 1. Okay, and if we go and find the y-intercept, that's when x equals 0. So we would have y equals negative 1 times plus 5. So if you see that, that ends up being 5. So the y-intercept is 5. So we can put those in. So we might say here's the x-intercept, 1 and 0, and maybe up here is our y-intercept, which is 5. Okay, and this is a negative graph up here, so we will start up in this corner, and it could go something like that. A pretty bad graph, but check it on the calculator. Okay, when you have graphs like the one up here where we have a factor that's squared, when you draw them, the squared factor, if you found that intercept, is the graph actually turns on that point. So it still has, it is an x-intercept of c, but it'll touch it and turn off it. So yeah, so it'll turn on that c value. So if over here where we do the, if we do the example of x squared minus x minus 1, just get that ruler off. So the x-intercepts, if you look, we would say let x squared equals 0. So x equals 0 is one's intercept, and x equals 1 is the other one. So because the squared term, we're going to see the graph turn on that, and then we've got another intercept of 1. So 1, 0, and 0, 0. Now because this is a positive cubic, starts down here, and we're going to see it come and turn, and then it whatever, and it goes up like that. So it touches on that one, and there's those graphs.